Imagine a world where devices aren't constrained by the size and shape of the batteries used. Drones fly higher, cars go further, your smart glasses last longer and they weigh less. So, my name is Gabe Elias. I'm the CEO of Material. Congratulations. You've all directly contributed to the energy supply crisis.
Ouch.
I really think the battery industry specifically is artificially constrained by the oversupply, obviously, that we know from. And that keeps the prices at a lower level than what's probably sustainable.
And how do you define success, Gabe? Both from a business perspective, but also for you as the founder, what would success mean?
If batteries... I'm getting a haircut today. I wonder if I should put a hat on or something. My name's Gabe Elias. I'm from Miami, Florida. I'm a gearhead engineer. I worked in the auto industry for 14 years. Used to design Formula One cars.
I'm Josh Muccio, and this is The Pitch, where startup founders raise millions and listeners can invest. Today on the show, Gabe Elias pitches a whole new way to manufacture batteries. He can 3D print them in any shape or size. Sounds rad. But why would you ever quit your job at a championship Formula One team?
I kind of started this company out of boredom. In my day job, I wasn't really being challenged. And I realized that there is no opportune time or good time to do this kind of stuff. You just have to kind of get out there and try. We want to take this to the moon, and we really hope these investors will see the vision that we have for it.
The pitch for Material is coming up after this. And whether you're watching or listening on YouTube, Patreon, or your favorite podcast player, thanks so much for subscribing. Don't forget to turn on notifications. Welcome back to The Pitch for Material. Let's meet the investors. Paige Doherty with Behind Genius Ventures.
What gets me to that hell yes conviction, it's a founder who deeply understands both sides of the business.
Will Weisman with Kitty Hawk.
We call ourselves kind of generalist frontier technology.
And Mark Phillips with 11 Tribes Ventures.
I'm a Midwest investor, so we have a different definition of price.
Hey, everyone.
Hey.
Hello.
How we doing?
Doing great. Mark,
Gabe, nice
pleasure to meet you.
How are you? Will.
Nice to meet you.
Great to meet you.
Paige.
Nice to meet you, Paige.
Nice to meet you.
Are we ready
You
to
ready?
go? Yeah.
We're ready, man. Tell us all about it.
So, my name is Gabe Elias. I'm the CEO of Material. I want you to think about your investment portfolios for a second. Any of you invested in an AI startup in the last 6 months? Maybe an eVTOL startup in the past 2 or 3 years? Maybe an EV startup in the not so recent past? Congratulations. You've all directly contributed to the energy supply crisis.
Ouch.
Energy demand, because of the bets we're all making, is far outpacing increases in battery capacity. And we here at Material are going to change that. Our manufacturing platform creates conformal batteries, any size, any shape, offering tremendous gains in efficiency and energy density. So I spent 14 years in the automotive design and development space, 7 years of which was in Formula One. And at every step of my career, I was working on a vehicle architecture that was inherently hindered by the size and shape of the batteries used. I met my co-founder, Dr. Chris Reyes, a couple years ago, and he told me he was the first person to fully 3D print a lithium-ion battery. I was floored. I never thought this was possible. I could have used that 5, 6, 7 times when I was in industry. And I knew at that moment, I had to work to commercialize this. So imagine a world where devices aren't constrained by the size and shape of the batteries used. Drones fly higher, cars go further, your smart glasses last longer and they weigh less. So we're manufacturing on the edge, we're consolidating parts, and we're shortening lead times with our novel manufacturing platform. And this is a way that we bridge the gap to energy demand. I'm here to raise $3 million to further our commercialization efforts and help actualize our pilot agreements in place. Thanks.
Cool, thank you. That was a great intro.
Yeah, that is.
I have to ask, is something on the laptop going to happen, or is that coming later?
Yeah, I can do it right now. I wanted to show you what this looks like in real time. So what's on the screen is a battery that we're developing for a company called Nimble. Nimble makes charging equipment for consumer electronics. That battery in the middle, that's a conformal battery. That fits in places others can't. And what it's done is it's increased the runtime and also given the designers of the product a unique ability to create the shapes that they actually want from the device that's just not previously available. It's hard to conceptualize what a conformal battery might look like. In reality, it can look like a lot of things. And that's one of the fun parts about it.
Wow, that's super cool. Can you tell us a little bit more about what the competitive landscape for conformal batteries looks like?
So it's pretty wide open. Our unique manufacturing platform is the first of its kind. It couples a in-house developed specialized material blend that uses our own nanomaterials and a manufacturing device which utilizes additive manufacturing and formable manufacturing methods. It's kind of a box that can make cheeseburgers. Think of it that way. It doesn't just make one part. It makes a lot of parts all together. And actually, that's the way a lot of manufacturing is going to go in the future. We're not just going to be making individual parts and sub-assembling them. We're going to be consolidating those processes into singular machines or maybe 2 or 3 machines that helps increase complexity, but also save money and time in the manufacturing process. We saw this as the pathway that the battery industry could go. But right now, they're very much beholden to conventional manufacturing methods and the crazy amount of investment that's gone into those methods.
And why are they beholden to those?
Well, the machines and the factories they've built and the contracts that are tied to those as well. With our method, we have the ability to be very agile for a customer. If they change the architecture of their device, for instance, we change the battery we make. It doesn't change the fundamental manufacturing platform.
Lithium ion only?
So we're chemistry agnostic, which is great. We're working on some of the emerging chemistries that are out there. Probably some firms that are pitching you new battery chemistries are ones that we can easily take, formulate into our own secret sauce, and be able to manufacture on our platform.
And you say platform, like what are the different components that are part of that? Like are you doing product design, CAD, all of that?
So we designed and developed our own manufacturing device, which takes pieces from additive manufacturing and formable manufacturing. We designed the battery that then gets manufactured in that device. And then we've also designed the materials as well. So it's kind of a fully integrated approach to this.
A lot going on there. Like with material, is there something that you consider to be kind of your secret sauce?
So our secret sauce is really our specialized nanomaterial blend that we developed in-house over the last couple of years. And what this allows us to do is create batteries without current collectors. That's how we can make these conformal shapes. It's something that's not seen in the industry right now. It is emerging, I would say, in academia, and you might see it from other players in the next decade. But we're first movers because we had so much experience prior to starting this company.
Gabe, can you talk a little bit about your journey
Oh, yeah.
to material? I heard F1 in there. That's super interesting. Lessons learned working in some pretty high intensity, highly competitive industries and how that's helping you shape material.
Yeah, absolutely. So when I was a kid, probably 8 years old, all I wanted to do was design cars, specifically Formula One cars. That was my goal. And I really worked my whole early life on reaching that goal. So when I started at Mercedes in 2014, I kind of reached the zenith. I was one of 2 Americans on the team.
Wow.
Living in England. And I won 7 world championships in that process.
What were you doing there?
I was a design engineer. So I got to work in multiple departments. I was in future car concept. I worked in powertrain integration, so I did radiators, worked on intercoolers, and then my last stop was in composite design, so carbon fiber parts, which if you know an F1 car is like 70% of it. I worked on a really interesting piece called a water-to-air intercooler. It's part of the engine. And this thing kept breaking on us all the time. It has thousands of these microtubes, titanium, aluminum, magnesium, all these different materials. And then someone in the office said, let's try 3D printing this whole thing in one piece. And we all just kind of looked to each other and we're like, all right, let's do it, And we spent 2 years working on this project to take a couple thousand parts and consolidate it into a single print. And that was the first time I'd ever seen additive manufacturing used in a high performance application.
Really cool.
I was floored. And I kind of just stuck it in the back of my head, that's cool. I hope that I can figure out a way to use that further in the future. So when I met Chris, my co-founder, and he told me what he was doing and how, you could create these multi-piece parts that hold energy and can be different shapes. I was like, hey, I saw the kind of the underpinnings of this in industry. I know people are doing this in other places. So I know we could do it in batteries. And that's why I was like, I really want to work on this. This is what we're going to commercialize. It allowed me to take my passion in automotive and really kind of funnel it towards new technologies and get excited about it.
I would be curious about IP and sustainable competitive advantage here. I mean, there's so much going on in the battery space. Like, it's pretty intimidating to want to start a new company in there, kind of given the amount of dollars and competition that's there. You must obviously feel like you've got some real secret sauce and something that's really a longer term kind of moat.
Yep, absolutely. We started the process on 5 provisional patents related to not only our process, the materials, the manufacturing method and machine. Those are all progressing. Patents are an expensive process, but we realize that protecting our IP is going to be paramount at this stage.
This is really cool. I love that it connects so much to your background in F1, like what you've been able to do already. I would love to get a clearer picture of the funding that you've raised to date, and then what are the key milestones that you have hit with that funding so far?
So we raised about $950K in the past year. With that money, we've went full-time. So it's 4 of us full-time now. We've created 3 multi-material, multimodal 3D printers. We printed over 150 batteries. And we've raised our energy density from initially pretty low levels and testing into now competitive rates. We've also undertaken a number of cycle testing. We have batteries that have reached 500 cycles. We're moving towards 1,000 cycles now. It's been baby steps. They say hardware is hard, right? It's been a great journey so far in the past year.
How about cost to manufacture compared to what people can get? I know you're doing kind of these novel shapes and allowing people to create products that normally they wouldn't be able to create. But how does it work out to be kind of cost per power? I'm not sure exactly what the right metric is.
No, that's right. In the industry, people have commoditized batteries.
Yeah.
So sub $100 per kilowatt hour is kind of like the metric you might hear from other people in the space. We expect to be able to manufacture at somewhere around the $85 to $90 per kilowatt hour. So it puts us in a competitive space for where we go to in the future. One of the major drivers for cost is obviously the nanomaterials. We were buying nanomaterials off the shelf from between $300 and $500 per gram. And for lab scale, that's fine for us to just do our experiments, but we can't be cost competitive or even have a company buying that. So we brought the manufacturing of these nanomaterials in-house. We lowered the cost initially by 10x, and we're going to get down below single digits per gram for our the material that we require. This makes us immediately competitive on the market and creating those batteries without current collectors that no one else is doing at the moment.
Yeah, I kind of would have expected you to initially be focusing on very, very high cost items where manufacturer really doesn't have a lot of other options and is willing to pay a lot. It doesn't sound like that's actually where you're focusing, though.
We'll be right back.
I kind of would have expected you to initially be focusing on very, very high cost items where manufacturer really doesn't have a lot of other options and is willing to pay a lot. It doesn't sound like that's actually where you're focusing, though, which it sounds like you're going kind of more consumer mass market, which to me is indicative of your ability to bring your costs down and really be competitive. Is that an accurate read? Or
Absolutely.
Can you just give us a little bit of a macro perspective on the go-to-market, recognizing that the industry does have some kind of fixed challenges as it pertains to bringing these conformal batteries to market? Mm-hmm. How are you going to overcome those challenges?
It's about finding the right customer initially, right? I like looking at patents that Apple puts out, for instance. They've tried to patent various forms of, we'll call it conformal batteries in their processes because they know that this is necessary. Almost every iPhone that's produced now is an L-shaped battery. Why is it L-shaped? Well, it's because we don't want our phones to die at 3 p.m. So they have to create a asymmetric battery to fit within the device using the unused space that's already there. They know this is the path. Everyone knows this is the way to go. They can't do it conventionally. It costs them billions of dollars to do it. The machines, the development time, the R&D to make those L-shaped batteries, for instance, is significant. And it's a process that they don't like going through. But if you use our platform, we get there quicker and cheaper. So we know it's necessary from the top to the bottom. It's really about finding those early evangelists like Nimble who say, hey, we really want to do something novel and unique in the market. And it's going to snowball after that hits.
Yeah. So the value prop is so overwhelming to the potential customer that the current infrastructure and the current challenges you believe will not be an issue.
Exactly. Once people see it and they see what it does and how it changes the products, they're going to shift.
I have a question on the customer side. So you said like for you all to manufacture nanomaterials yourself brought the cost down like 10x.
Yep.
Are you finding in your customer conversations that this is like a build versus buy decision? Like, is there other alternative to try and build this technology in-house?
Depends on the size of the customer.
Okay.
Most of the people are buying batteries, right?
Got it.
And then most of the manufacturing players, let's say a Panasonic, they're also probably buying a lot of their manufacturing equipment to make batteries.
Got it. So materials is kind of like a hybrid approach, right? It's not necessarily that they're buying batteries and it's not necessarily that they're building them. They're using your platform to bring down costs without having to directly build in-house.
Exactly. I mean, that's the best way to put it right there. It's a hybrid approach and allows small companies to maybe act more like the big companies that would build that in-house. You know, we haven't been talking to two big companies, let's say the large manufacturers yet. We've been working on people kind of like mid to lower tier on purpose because we can be more intimate and help us develop our manufacturing process. We need to learn as much as they need a product, and our pilot customers are the ones that we're engaging with, making samples for, designing batteries for. Those learnings help us grow into being able to actualize a contract with an Apple or a Meta, for instance, on their new devices.
What type of margins do you generate?
Well, I guess it depends on the complexity, but you know, I'm going to be targeting in the 25 to 30% margin, at least at the early stage.
Got it. Yeah, I guess like what are the pricing levers that you think about?
Chemistry that we utilize.
Okay.
So the raw materials. Our nanomaterial blend is kind of unchanged, but we do change kind of volume fraction. So some batteries might have more or less depending on performance requirements. But these are all customizable and they really don't cost us as a company much of anything to make that change for each customer.
What will the capital needs of the business be moving forward, in addition to this $3 million round?
You know, building out facilities to manufacture is not a cheap endeavor. So there's going to be significant upfront capital costs there. We have the ability to sell not only our manufacturing machines, but the batteries themselves. So there's two real verticals there, and the machines come with a razor blade model. They have to use our materials. So we're still kind of trying to understand whether or not we want that to be a second vertical and sell the machines or just do all the manufacturing in-house. It is open-ended in a way. How it turns is really how the market responds to us, and that's what our seed raise is for, is getting that product market fit out of this. So,
And how do you define success, Gabe? Both from a business perspective, but also for you as the founder, what would success mean?
If batteries in the devices that we use and take for granted just fundamentally look different than they do now, just the way that we integrate smart electronics, AI, the way your car looks, the way that we interact with those devices is going to change fundamentally if our technology takes hold, and we expect it to. And that's a world where you're not even going to really know if you're in, let's say, a petroleum-powered device or vehicle versus an electric-powered vehicle. And that's when the energy transition happens. So if we can be a part of that, then I deem this as a success.
Well, Gabe, I really appreciate the opportunity to learn about material and want to congratulate you on your journey and what you're building here. Unfortunately, it's not going to be a fit for me and for Kitty Hawk. I would say there's two primary reasons behind that. One is just the dynamics of this space, just the sheer amount of competition in the battery space, the amount of companies out there going after these problems and dollars that are being funneled into it. Also concerned about the gross margins at this point. I'd want to see much higher margins, or at least a path that could get me to significantly higher margins. And I just think that speaks to unfortunately, the intensity of the competitive dynamics here and inability to kind of hold the price where you want to. So love to try to be helpful however I can, but not going to be a fit for me.
Thank you. It's all good.
Your experience in F1, you touched on it. How is that informing how you're building material?
It's allowing us to be lean and fast. The things I was able to do in Formula One would take a conventional auto manufacturer probably 4 or 5 times the amount of time and money for that matter. The automations, the speed, just knowing what a good team looks like, just a high performing team that I was a part of. I carry that with me, I guess.
I bet.
Every day.
That's a great question. I love that.
It's one of those things that to be a fly on the wall in that building would be amazing for some people. And for me to be able to experience it and take so much from it it comes up in every day, every single day at the company. And I do feel like it makes me a bit of a demanding CEO in a way, because I know what excellence looks like. I saw it up close. Designing a car that goes 230 miles an hour and wins all those championships. And everyone that went into that was truly excellent experience. And even being able to just bottle up 5% of that and sell it around the world would be, I think, a crazy business in itself. So
Yeah.
yeah.
I really appreciate that. And I appreciate the commentary around your kind of leadership style. How do you perceive failure in the context of a healthy, demanding culture?
Really, just no blame culture. That's something I did learn in F1 from Toto of all people.
Yeah,
And
it's a good teacher.
you know, I had very famous failures when I was in F1. I designed a radiator, and I think we got to the second test in Barcelona, probably a week before the season starts. My radiator's, shooting out water in the paddock, and I'm like, oh crap, what happened? All the things that we did in this process a week out before the season starts, like, what's going to happen? I thought I'm going to lose my job immediately. No, literally just got together, did a crisis, kind of a failure analysis right there. We had a solution on the car in probably 3 days flat in Barcelona. And it was really so cool to see just like everyone kind of like come at the problem like a bunch of ants, and just no one cared why we got there. It was just like, let's fix it, let's move forward, and let's do it quick.
It's awesome. It's a great team. The cultures we look for are the ones that are highly challenging but highly supportive. And it sounds like you've experienced that. It's really cool. I talk about founder market fit a lot, Gabe, in the sense of the people who are building something and their experience. And I think you personify that. I really do. It's super exciting to hear about the hard work you've put in to get to F1. I can't imagine what that was like. And then bringing that now to material. From an 11 Tribes perspective, what we're looking for are businesses that require significantly less capital, but it's the only way to make a business like material successful. So it won't be a fit for our fund. There are a couple of different funds that I can think of that I'd like to make an introduction to. I think are more interested in the hardware space, in the battery space, and certainly want to be helpful, because I do feel like you're bringing just an incredible wealth of knowledge and experience to a business that has a ton of potential, but it won't be a fit for our firm.
I appreciate that.
Yeah,
and,
of course.
Appreciate anything you could do
of course.
On those intros. Thank you.
100%.
Yeah.
It sounds like a lot of the concerns that we have at the table today are on the margins of the business. I'm no stranger to hardware. We've invested in 5 hardware companies to date at Behind Genius, and I know how difficult hardware is. So I guess my question to you is like, are there significant higher margins in any like iteration of the business? Because that is like a concern of mine, and we definitely look for, when we invest in hardware businesses, look for higher margin.
Yeah, no, absolutely. And it really comes down to the battery complexity or the part complexity that we develop. When we start consolidating other parts, that means we're consolidating other manufacturing steps. We take, let's say, a battery pack that might have 700 cells or something like that. If I can turn that from a total of, let's say, close to 1,000 parts, and I can make that into 20 parts, the cost of the battery material might be slightly higher at that point. But the overall cost of the assembly, I can drag down to the bottom of the ocean very, very quickly there. And
but that's the question is like, yes, you can drive the cost down to the bottom of the ocean, but like the margin of the business and the value that you're providing shouldn't also be dragged down.
So at that point, margins will go up, I guess is what I'm saying. Yeah. So it really depends on the use case. This is a tool, and you as an engineer should know, when you get a really cool tool that does something that you haven't been able to do, I mean, your eyes light up.
Yeah.
You're like, this is awesome. I can really change whatever my boundaries are. Look at us as that tool. What you can do with this, I mean, being able to combine this with advanced manufacturing techniques, it opens a world where those 20 to 30% margins I'm telling you about immediately could go much, much higher, really depending on how someone's vision of using our manufacturing platform goes.
I guess that's grounded in like someone else's vision for the company. And I want to hear about like your vision for driving the company towards that. Does that make sense?
Sure. Yeah. The thing that we are a key benefactor of is the nanomaterial development.
Yeah.
It's the highest cost portion of our whole battery, for instance. Driving that cost down in order to make this available for the masses in so many different use cases, supercapacitors and in chips, in other electronics devices and solar panels, things like that. It has so many, I guess, knock-on effects. So we've started with bringing that in-house and really highlighting that as a key differentiator, and driving the cost of that down specifically is what's going to kind of help us open up more applications and better prices, I guess, for customers as well.
Yeah. The answer I was looking for was more around like, here's where we can charge more for the value that we're providing versus bring the cost down. This is like my core hesitation with the business. So I want to give you like an ability to really explain your thoughts around like both aspects of that lever.
Yeah, people are definitely willing to pay a premium for what we're offering them. And that really comes down to being able to show value with the complexity that we can provide in these battery packs. I really think the battery industry specifically is artificially constrained by the oversupply, obviously, that we know from China. And that keeps the prices at a lower level than what's probably sustainable. So people are expecting to pay less and less for some of these pieces of equipment. It's about finding customers who understand the value proposition as well as you guys do and some of our pilot customers. Will allow us to increase the cost as we increase the complexity and the value that we deliver to them. So, I mean, it's just open-ended how far it could go, but electronic devices, hopefully in the future, are going to be so many less parts, and that's going to come down to this kind of optimization, and it's going to give us better products and probably will increase the margins on our end as well. So,
Cool. Yeah. Well, thank you for all of that. I think from my perspective, as I mentioned, I would like to see more clarity on getting to the higher margin potential of the business is what I would need to see to have like a hell yes conviction in the business. I think you're an incredible founder, and I really appreciate the stories that you shared about F1 and your approach to engineering. It's really hard to build hardware at the speed that you've been able to do it, like the different cycles. So I really appreciate that. But unfortunately, it won't be a fit for Behind Genius due to the margin issue.
Okay, all good. Thank you.
Yeah.
Appreciate it.
Thanks, Gabe.
Yeah.
Appreciate
Thank
you.
you, Gabe.
Yeah, all right.
Yeah.
Thanks all.
Cool.
See ya.
That was tough.
That was tough. Amazing.
That was really tough.
Yeah. Amazing founder.
Yeah.
I love that story.
Really liked his story.
Yeah.
When he said 30% margins, I was like, roll it back, roll it back.
Roll it back.
Yeah. Yeah. Yeah, I mean, I just really would have expected him to be focusing on, especially in this early stage, they're doing something that's so unique and will add so much value to certain customers that you should be able to extract much, much higher margins. And so in general, like the battery space to me is a really tough space to invest into.
Does it speak to the customer's willingness to pay?
From my understanding, I feel like the customers are paying the premium, but it's like
15%,
commanding.
20%.
Yeah, but I
premium.
think like, because he's like been in the engineer's shoes and he knows how expensive it is to do this. And so I think he's really excited by bringing the cost down, but not necessarily like charging for that improvement or like charging for the complexity. And that might be like a very capitalist thing to say, but I'm like, you're providing a lot of the value for the business. So charge what you're worth.
Do you think it's a confidence thing? Like he's a first-time entrepreneur and doesn't quite have that?
I think it's more like he has so much empathy for the customers that he's working with, where he's like been frustrated with it himself, and he knows that this is a really important problem he's solving. So I don't know if it's a confidence. I feel like it's like the perspective and an angle of the business. I think what I've seen in like the higher margin hardware businesses is like you start with a very high margin, smaller run product, so you can build like a very capital efficient business. And then as things get to more scale, then you might lower your margin, but you're making higher volume, versus this feels like he's taking the lean fast approach the full way.
Yeah. But I'm 100% with you. I would have expected the democratization to happen a little further along, and especially not in the earliest
I kept asking
stages.
him, and I was like,
I could tell you were like trying to.
I was like,
I'm trying to give you the right answer. Tell me what this looks like at scale.
if you're providing a lot of value, then charge for it.
Yeah.
He could have so much pricing power in this business.
Yeah, that's
Right.
what
That's
I'm
what's so
saying.
surprising. You can bring products to market that no one's ever been able to do with this.
Yeah.
I would think with unique capabilities. I mean, they're so young and early, and maybe they just haven't gotten out there. And he went towards something that was easy and right in front of his face.
Yeah.
Instead of finding something like teaming up with someone to create something that was world changing, where they could get an unbelievable margin from it.
But he told us what he thinks, and I think
Yeah.
you touched on it. It's the empathy. He wants to be part of the energy transfer.
Yeah.
He wants to change the world, which is amazing. And I think he's willing to sacrifice on margins to be a part of that.
You got to be able to raise capital to be able to
Yeah, I was
fulfill
going
your
to say
business.
that's probably like one of the
needs
biggest challenges in hardware is like raising capital, and that's like 100% going to be the concern for like most of the investors that he'll talk to.
So when you look at a business like this, we have a first-time founder, clearly has insane domain expertise and comes at this from the engineer perspective. Like at some point, he's going to realize that like as I build this, like I have to build in pricing power and pricing leverage because that's how I'm going to build a big business that actually scales. In your decision-making process, Paige, like is there a part of you that's thinking, okay, you didn't give me the right answer there, but maybe this tech actually has so much leverage that like he's going to realize how much pricing power he has. And if he has you and maybe some of the right investors on the cap table, like they can show him how to use that leverage to build a big business.
Yeah.
Or do you feel like you just have to,
It's
the
hard
founder
to
has
say.
to see that vision?
I feel like the bar for excellence is really high. Like I've talked to founders who like have a command of like the technology and the like levers they can pull to like charge for the value that they're providing. So when I think about what gets me to that like hell yes conviction, it's a founder who like deeply understands both sides of the business.
Yeah. This feels like one to keep watching.
But that was tough.
Yeah, for sure.
That was tough.
That was tough. Yeah. His backstory is, I mean, that whole
Exceptional.
mindset. I loved your
So
question
awesome.
about like the culture and how he leads and all that. And it feels like there is the potential for something really special.
Yeah, I think he's
there.
a special guy,
Yeah.
special founder.
Yeah.
Yeah, for sure.
Yeah.
All right. Break.
Yeah.
Gabe walked out of the pitch room with zero commitments and his battery fully drained. The 30% margins killed the deal. But what if there's actually a big, juicy margin hiding in the tiniest part of this business? Paige puts material under the microscope after the break. Welcome back. Paige passed in the room, but you could tell she didn't want to. So she jumped on a call to give Gabe one more shot at the margin question.
Hey, how's it
Hey,
going?
good to see you, Paige.
Good to see you too, Gabe. How have you been?
Been great, very busy. Actually, very timely for be able to speak to you because we have over a third of our round committed. We have 1.1 committed so far.
That's
Yeah,
awesome.
things are moving forward. And I kind of left the pitch event and I was like, I really want to speak to Paige again because I just feel like maybe there's just something that could be done to kind of pull you in on this. And so I'm glad we could at least get together to speak.
Yeah. The main thing I had circled from our conversation that I wanted to talk about, margins, 25 to 30%.
Yeah.
Let's talk about it.
Yeah, to give you a little bit of background, we were looking into the battery industry and the margins that were available for the industry for conventional manufacturing. They're in the single digits percent.
Yeah.
And that's over billions of cells made, globally every year. A lot of that is because of the materials. We built up a very detailed model that explained where our largest cost drivers are. In spite of our nanomaterials being the most expensive portion of this whole thing, we're still able to achieve a 20% margin on batteries at an all-in production cost of $390 per kilowatt hour. So when you think about consumer electronics, where the prices are between $300 and $3,000 per kilowatt hour, we actually slot really well in there and offer an ability to actually increase our margins depending on application. We got great evidence from a customer we're talking to now that wants computer batteries, laptop batteries.
Yeah.
They're buying at somewhere in the $950 to $1,000 per kilowatt hour range. We expect to be able to make a battery just under $400 per kilowatt hour, including 20% margin.
Here's my issue with that is like you're providing a technology that they don't have. If you're thinking of it on just like a cost per kilowatt hour basis, that would make sense if you weren't providing something novel. But from my understanding, like the novelty is that you can build a battery in any shape. So like, why wouldn't they pay more for that?
It's about being competitive because I have to be able to pull customers into my form factor, and I have to do that in a...
Wait, back it up on that. Is the form factor not what's pulling them in already?
So they'd want to work with us because we had more capacity on device.
Okay.
Also able to make batteries lighter and more volumetrically efficient.
I'm not hearing because we're the cheapest option on the market and we're going to continue to be.
No, but we're not, because we're at, almost $400 a kilowatt hour. But we're not the most expensive option. We're a competitive priced option.
Here's what I would absolutely love to hear, and I totally understand if this is not your philosophical alignment with the company. I would love to hear, Paige, we're going after the absolute highest margin batteries where people are paying $3,000 per kilowatt hour for these specialized batteries. Here's how big that market is, and we're gonna make the best product. That may not be your alignment as a business. I just want to be transparent with what I would be looking for in this space.
Yeah. Look, I think philosophically we're definitely aligned. I want to sell batteries as expensive as possible to as many customers around the world and make as much money doing so. I think that's
okay. Yeah. I feel like we were kind of beating around the bush before, though. You know what I'm saying?
So I guess I had my customer hat on, right?
Different customer on this call.
That's true. No, you're right. I do think you're essentially right here. The materials are what the limiting factor is on margins, right?
Okay, well, is that true? Is that true? Because it also feels like the price that you set them at is part of that too.
So our nanomaterials were very expensive at lab scale. We've actually developed a way to manufacture these nanomaterials at fractions of a dollar per gram, which is, 100x cost decrease over what we have in the lab.
You're telling me you're something that's 100x margin product?
Sure.
And you're I'm going to sell another product that has 20% margin and look at increasing it.
Yes. You bring up it's a great point.
Why not become a nanomaterials provider? Sorry, I'm just trying to poke all the holes possible.
I'm already ahead of you. I'm already speaking to people that want to purchase the materials because we can make them internally cheaper than we can buy them on the market.
I know this is I'm usually not very prescriptive with my advice, but I feel like if I was you, I'd just be we're making nanomaterials, get in the car.
It's a significant thought at the moment.
How much of this could you sell?
We can sell hundreds of kilos a month probably of this stuff.
How much would you sell a kilo for?
So let's say I was selling them for sub $10 a gram, right? So that's 10 times what? There's 1,000 grams in a kilo, right? So it's $10,000 a kilo.
Okay. I
could sell hundreds of those, probably 100 a month. So you're at, it's $1 million just for 100 kilos.
So you could sell $1 million at 100x margin.
With some investment to build out our little nanomaterial factory.
So you could sell $1 million a month. Is that a conservative estimate?
I think so.
What is keeping you from betting the whole ship on this?
It's because it's a subcomponent. Not everyone has to use it. So it's just more about understanding the markets, where things are going. What I can say though is it's a key component of our batteries and our manufacturing process.
Yeah.
And the more learnings we gather during this process of figuring out if they work, how they work, who can use them, I think it'll open up that vertical quite quickly. So you just kind of have to wait and see. If you want to give us some money to pursue it, I'm happy to make that our sole priority here.
If I'm being totally honest, I think it would be hard for me to get to hell yes without having a clear answer on the market sizing. That sounds like a really compelling opportunity, and that would be one that I would be probably more interested in than a competitively priced battery.
We know we're on the right path here. I think there's just because we're a pre-seed company going into our seed raise here, there's still a lot to learn in that regard.
Yeah. Thank you for humoring me on going down that path of what it could be.
Yeah. Okay. No, that's what I'm here for, I suppose. So
You know, it kind of feels like Gabe doesn't want to build a nanomaterials company. He really wants to make weird-shaped batteries. Fair enough. It is his company after all. Luckily, Gabe is finding investors who agree with his vision. He's closed $1.5 million of his $3 million round. And they just got the keys to their first dedicated facility in Miami. We'll share an update in the season finale. No offer to invest in material is being made to the listening audience on today's show, but you can join our private investor community on Substack, where you'll get access to the deals we're doing behind the scenes. So, if you're an accredited investor, you can apply to join at thepitch.fund. Next week on The Pitch.
1 in 5 people in the world are students. But unfortunately for most students, studying sucks. Why does it suck? We're told what to learn, but we're rarely ever taught how to learn.
What I'm hearing from you in that story is having a personal breakthrough about who you want it to be, and then you going and changing all of these habits to be in alignment with who you want it to be. That's a little bit different than what your company is doing.
I just see learning as a superpower in general.
I'm curious how you've acquired the 180,000 monthly active users.
A lot of grinding. In the last 3 months, we've spent $105,000 to make $108,000. My co-founder, he got us this little hat called experiment mode. I think the best founders are the best experimenters.
Yeah.
And
100%.
thinking like scientists is what really matters.
You're an A+ founder.
I normally don't like ed tech, but I really like you.
I feel like I'm the lone dissenter.
Ooh, Charles, spicy.
I'm sure when they air this episode, they'll be like, Charles was really dumb.
That's next week. Season 13 is available to watch on YouTube and Patreon, or listen on your favorite podcast player. Applications are open for Season 14 of The Pitch. So if you're raising capital for your startup or plan to raise in the fall, apply to pitch at pitch.show/apply. You don't even need a deck. Just fill out our quick form at pitch.show/apply. We'll see you next Wednesday in the pitch room. This episode was made by me, Josh Muccio, Lisa Muccio, Anna Ladd, Enoch Kim, and Jackie Papanair, with deal sourcing by Peter Liu, John Alvarez, and Phoebe Sun. Music in this episode is by The Musemaker, Breakmaster Cylinder, Wilson Trouvé, Our Many Stars, Boxwood Orchestra, Hidden State, Peter Jean, and The Runaway Queen. The Pitch is made in partnership with the Vox Media Podcast Network.